So Albert Einstein comes up with one of the most revolutionary ideas in all of human history. But here's the thing. This isn't just about the science. It's really the story of how he tried to explain it to, well, to everybody. And his tools? A simple little booklet, some really clever thought experiments, and, let's be honest, a whole lot of patience. This is how one book completely changed how we see reality.
Okay, so the story kicks off with a perfect bit of irony. After he finished writing his popular book on relativity, Einstein himself joked that the label on the cover, generally understandable, should probably say generally not understandable. He was basically saying, yeah, good luck with this one, folks, convinced that the average person just wouldn't get it.
And yet, here's the twist. This book that he joked was impossible to understand, it was a massive bestseller. In just the first 5 years, it went through 14 printings in Germany alone. So what was going on?
And that really gets to the heart of our question here. How on earth did a book that even its own author called wooden and not understandable become this global sensation that literally changed how we see the world? Well, the answer has as much to do with the man as it does with the physics.
See, Einstein wasn't some academic locked away in an ivory tower. He actually saw himself as a kind of missionary for science. He was on a mission. He wrote this letter to his friend Michel Besso back in 1916, and it's super revealing. He says he has to write this book. Why? Because he believes that deep down, his theory isn't complicated at all. He thinks it's fundamentally simple, even beautiful, and he felt like maybe he was the only one who could get the rest of the world to see that. So his number one goal was just clarity. Pure and simple. He literally said he wasn't trying to write elegantly. He even quoted another physicist saying that stuff like style, you can leave that to the tailor and to the cobbler. All he cared about was making these huge ideas stick. And believe me, the main idea he had to get across was a real mind-bender. He had to somehow convince people to throw out their most basic, common-sense ideas about reality. And he started with the one thing we all think we understand: time. And to do it, he came up with this brilliant thought experiment. So, picture this. You've got a train track. 2 lightning bolts strike the track at the exact same moment, one at point A, the other at point B. Now, here's the question. Does everyone, no matter where they are, agree that those 2 strikes happened simultaneously? All right, let's walk through this. If you're just standing there on the embankment, right in the middle of where the strikes happened, the light from both flashes travels the same distance and hits your eyes at the exact same time. For you, yep, they're simultaneous. Easy enough, right? But now, let's put you on a speeding train. The game completely changes. You're moving towards one of the flashes and away from the other one. And since the speed of light is always constant, the light from the flash you're heading towards has a shorter trip. It reaches you first. So from your perspective on the train, the events are absolutely not simultaneous. And this leads to a really profound, kind of weird conclusion. Simultaneity is relative. What that means is there's no single universal now that everybody in the cosmos agrees on. Time isn't just this rigid clock ticking away for everyone at the same rate. It's actually woven together with space, creating this 4-dimensional fabric we call space-time. Okay, an idea that radical, it's gonna need some serious proof. And boy, did it get it. The proof arrived during one of the most dramatic scientific moments of the 20th century. So Einstein's big theory, general relativity, made this absolutely wild prediction. He said gravity isn't some invisible force pulling you down. Nope. He said that huge objects, like our sun, literally bend and warp the fabric of space-time around them. And if that's true, it means that light from a distant star passing near the sun shouldn't travel in a straight line. It should follow that curve. We should actually be able to see it bend. So how in the world do you test that? You can't see stars next to the sun, it's way too bright. The solution was pure genius. Wait for a total solar eclipse. A British astronomer, Arthur Eddington, led an expedition to do just that during the 1919 eclipse. The plan was to photograph the stars right next to the sun while it was blocked out. Then, they'd compare those photos with pictures of the very same stars taken months later, at night, to see if their positions in the sky had actually shifted. And this table here, it shows you exactly what they found. When the teams in Brazil and West Africa developed their photographic plates, the results were just astonishing. The amount the stars appeared to have moved was an almost perfect match for what Einstein's crazy equations had predicted. He was right. He was absolutely right. You could imagine what happened next. The news just exploded. Headlines, like this one from the Times of London, screamed about a revolution in science. Newtonian physics was overthrown. Literally overnight, Albert Einstein went from being a well-respected physicist to a global superstar. And there was something else going on here, something deeper. Think about it. The world was just 1 year out from the end of the brutal, horrifying First World War. And here you have a team of British scientists confirming the theory of a German-Swiss scientist. It was this incredible symbol of how science could rise above nationalism and bring people together.
So now the theory is proven, and suddenly everyone wants to get their hands on that little booklet Einstein wrote. Demand just went through the roof.
The book got translated into, well, practically everything. English, French, Japanese, Hebrew, you name it. His ideas were spreading like wildfire across the entire planet. It seemed like everybody wanted to at least try to understand this new universe Einstein had revealed. And the numbers here are just staggering. I mean, look at this. 14 editions in German, 5 in English, all within just a few years. That little book that Einstein worried nobody would understand had become required reading for the whole world. So in the end, relativity did more than just change physics. Because Einstein was so committed to explaining it, to sharing what he saw as its basic, beautiful simplicity, it became more than a theory. It became a shared human endeavor, a cultural moment where we all try to wrap our heads around the cosmos. And that kind of leaves us with one last question, doesn't it? Einstein proved that it's not enough to have a world-changing idea, you need a world-changing explanation to go with it. It really makes you wonder, what's the next big idea out there right now, just waiting for someone to come along and explain it to the rest of us?